Did you know that the fuel in cars, the cooking gas in your kitchen, the plastics we use daily, and even candles all come from the exact same chemical family? They are all hydrocarbons. Welcome to this explainer. I am absolutely thrilled to have you here. If you're a student prepping for your CSEC Chemistry exam, consider this your ultimate super focused roadmap. Today, we're going to make the organic chemistry section on the sources of hydrocarbon compounds completely easy, visual, and totally exam focused.
All right, let's dive right in. What you're looking at here is the absolute gold standard for your studies. The official CSEC Chemistry syllabus, blueprint for Section B, which is organic chemistry. We aren't guessing what might be on your test, and we definitely aren't wasting time on extra fluff. Every single concept, keyword, and objective we cover today is pulled directly from this source document. We're focusing strictly on exactly what the examiners expect you to know.
So, here's our quick exam roadmap for today. We're hitting 4 key stops: organic chemistry goals, natural sources, fractions and uses, and finally, cracking processes. Let's get to it.
Section 1. Organic chemistry goals. The big picture.
Before you memorize anything, you've kind of got to understand the big picture. Think of this whole section as a giant puzzle. You are learning exactly where these carbon compounds come from, what their structures look like, and how their unique nature dictates what we use them for in the real world. You'll be classifying these carbon compounds based on their functional groups, as well as their physical and chemical properties. The examiners have laid out a really clear path for us with these 5 general objectives. It goes from understanding their formation from natural sources, all the way to bonding, reaction patterns, and polymers. Today, we are zooming in heavily on that very first step, understanding their formation from natural sources. Section 2, Natural Sources, Specific Objective 1.1. Okay, this is a big one. Whenever the exam asks you for the natural sources of hydrocarbons, there are exactly 2 answers you need to provide: natural gas and petroleum. That's it. Natural gas, which you might know is mostly made of methane, is found in huge underground deposits. Petroleum, on the other hand, which we often call crude oil, is this thick, dark liquid mixture of lots of different hydrocarbons. Lock those 2 sources into your memory for sure. Now, what's really interesting about this syllabus is a massive pro tip hidden right in the skills and interrelationship column. The CSEC examiners actively want you to connect your chemistry knowledge to your other subjects. When you study natural gas and petroleum, think about forms of energy from physics and ecology and natural resources from your biology class. Trust me, understanding how these chemical sources function as energy and impact our ecosystem makes the chemistry itself so much easier to remember. Moving right along to Section 3, Fractions and Uses, Specific Objective 1.2. So picture this. Raw petroleum pumped straight from the ground isn't actually that useful as is. It has to go into a massive fractionating column where intense heat is applied at the bottom. Through a really specific separation process called fractional distillation, it separates based on boiling points. The smaller, lighter molecules rise to the top as gases, while the larger, heavier liquids settle near the bottom. This incredible process gives us all our distinct, usable fractions. So what do we actually do with all those separated fractions? Well, the exam requires you to list the main uses for at least 3 of them, but pay close attention to the fine print here. The syllabus explicitly mandates that the uses you describe absolutely must include fuels to run things like cars and airplanes, petrochemicals for making things like plastics, and lubricants to keep our engines running smoothly. And here is a quick exam cheat code to tie that all together. Remember those cross-curricular links we discussed a minute ago? The use of these specific fractions, especially as fuels and lubricants, directly impacts biological ecology and physical forms of energy. Keeping that physical energy output and the environmental impact in the back of your mind is going to help you write much stronger, more comprehensive exam responses. Section 4, Cracking Processes, Specific Objective 1.3. Just knowing the uses of those distillation fractions isn't quite enough to get you full marks. You also have to describe the cracking of those petroleum fractions. Cracking is exactly what it sounds like. It literally breaks down large, clunky, less useful hydrocarbon chains into smaller, highly useful molecules, like the kind we use to make plastic water bottles. You specifically need to distinguish between 2 different types of cracking. First up is thermal cracking, which relies on intense heat to split the molecules, and then there's catalytic cracking, which uses chemical catalysts to speed the whole process up. Plus, the syllabus explicitly ties both of these processes to a specific homologous series, alkanes. So your main focus needs to be on describing how these 2 methods are used to crack alkanes. Wow, we have covered a lot of precise ground today, straight from the source. So, quick self-check. Can you confidently list the 2 natural sources, 3 uses of fractions, and the 2 types of cracking? If you can mentally check those off, you are totally ready for the exam. But here is a final thought to chew on. As the world pushes hard to transition away from these very fossil fuels, what do you think will ultimately take the place of petroleum in our everyday lives? Keep reviewing, stay curious, and thanks for hanging out with me on this explainer.